Hi guys, so in this class we'll start with the remaining functions and their graphs. Last class I did identity function as well as a constant function. The third function, which is a polynomial function. This is the third one. Polynomial function, we can define it by, it's a function f which is mapping from real number R to R is said to be a polynomial if each x is in R, then the function y is nothing but f of x. We can write this as a0 plus a1x plus a2x square plus a3x cube plus etc. so on plus an x power n. So as you guys know about this one, this is a general form of the polynomial, and in this, where n is a non-negative integer, non-negative is nothing but it should be a positive non-negative integer, and a0, a1 etc. till an, these are the constant which belongs to real number R. So here the domain and the range, the both are in real number. So domain of a polynomial function is a R and the range is also R. So in this you have to consider the function, or sometimes they'll only give you the function. Okay, so I'll just take one example for a polynomial. So if they'll ask define a polynomial function, write the domain and the range and it's a graph. If they ask like that, you need to define like this, then you have to write the domain and the range, then you just consider one function, then you just plot the graph. So I'll just take the function y is equal to f of x is equal to x square. Is it clear? This is a polynomial, right? X square, and x is in R. I'll just consider a table for this. X values, where y is nothing but x square, it is a polynomial. If I take x is minus 3 and this will be minus 3 whole square is a 9. If I take minus 2, you will get a positive 4. If it is a 1, you will get a 1. 0, 0. 1 is 1 again. Then positive 2 is 4 itself, and a 3 is a 9. Okay, because the function is a square is there. If you take a negative square, you will get a positive only. Now you just plot the graph for this. Till 9 is there. So what I'll do is, I'll just divide the scale by 2 units. X, x dash, y, y dash, and this is a 2, 4, 6, 8, 10, minus 2, minus 4, minus 6, minus 8, minus 10, then minus 2, minus 4, minus 6, minus 8, minus 10, and 2, 4, 6, 8 and a 10. You just plot it now. When you will take x is a minus 3 in between here. If you take negative x as a 3, then the y will be a 9. So somewhere here, I'll just take here, this is a 9. When you will take x is a minus 2, then y is plus 4 here. When x is a 1, in between this, y is 1, x is 0, y is also 0. Next, x is plus 1, y is a plus 1, x is plus 2, y is plus 4, x is a 3, y is a positive 9. Just join it. Okay, this is what the function y is equal to x square. Hope you guys understood this polynomial function. You need to define this, then consider a function, construct a table, plot the graph, then write the domain and a range. If they didn't mention in the question like write the domain and a range, even though you need to write the domain and a range for the function, okay? So for a 5 mark, they'll ask a compulsory this, not a polynomial. Out of these function, any one will be 100%, okay? So next is a modulus function. Fourth one, modulus function. So here the function which is defined by f of x is equal to mod x. For each x is in R and is called modulus function. Modulus function. Now this value is, or this function is like a double valued, is nothing but x is positive also you will get and a negative also you will get. When the function is like a modulus, you will get two values, one is a positive and one is a negative. When this is a positive means x is greater than or equal to 0, and you will get a negative values when this is a less than 0. So this is what a modulus function. So now for this you can write, or else you can take a table like this is a x and y is a mod x. So now this is a minus 3, you will get a plus 3, minus 2 plus 2, minus 1 plus 1, 0 0, 1 1, 2 2, 3 3. So modulus is nothing but a modulus of any negative value, which is like minus 4, we can write it as a plus 4. But the value will be a two values modulus. So it is a negative value as well as a positive value. But while writing the modulus of any value, if it is a negative, you will get a plus. If it is a plus, obviously this is also a plus. Okay. So therefore here, if you take x value as a minus 3, y is a plus 3. It is a minus 2, then plus 2, minus 1, plus 1. All the positive will get a positive itself. Then how exactly the graph will be for the modulus is (1, 2, and a 3), minus 1, minus 2, minus 3. This is minus 1, minus 2, minus 3, y dash, x, x dash, and a y, 1, 2, and a 3. When you will take x value is a minus 3, y is a plus. When x is a minus 2, y is a plus 2. When x is a 1, plus 1, 0 is a 0. When x is a 1, y is also 1. When x is a plus 2, y is also plus 2. X is a plus 3, y is also plus 3. You just join it, you will get a graph which is like this. So this is what the modulus, and this we can call it as y is equal to mod x. Modulus means what? You will get a negative will be a positive, and positive is remains same, which is a positive itself. So I will write the domain and the range. It's nothing but domain is R itself, and the range is also R plus. Okay, positive values, only a positive. Next I can go with Signum function, and this is the important one. Signum function. So here the function is defined like directly we can define this as 1, 0 and minus 1. Only 3 values for a function. When this is the 1 means greater than 0. If you take any positive values, the function value remains same, that is a plus 1. And this is exactly 0. And this is a less than 1. Means if you take any positive values of a x, the function value is remain same, that is a 1. If x is a 0, the function is also 0. If you take x value as any negative values like a -3, -10, -100, whatever it is, negative value, the function values remain same, that is -1. So by seeing this, you can write, so this function is called as a Signum function. The domain is R. You can choose any values of x that is in a real number, but the range you will get only 3 values. The range is the function values, which is 1, 0 and -1. This is what the range. Okay. Then how exactly the graph is? Nothing but. Hope you understood this function. This is the important one. Y is equal to, I can write the Signum. We can't write directly the function here. A triple valued function is there. If you take any x negative value, you will get, which is a negative means -1. Next -2 means -1. -1, -1 only. 0, 0. If you take a positive any value, it remains the same, that is a 1 itself. 3 and a 1. Hope you guys understood now. Okay. Any negative value of x, you will get the function value is a -1. It is remain same. If you take any positive values of x, then the function value will be a +1 it is. Then the graph will be. So anyway, it is only a 1 and -1, so I'll just take it like freely. X, x dash, y, y dash. Okay, 1, 2, and 3, -1, -2, -3, 1, 2, and 3, -1, -2. So now if x is a -3, y is a -1 here. When x is a -2, y is a -1. X is -1, y is also -1. When x is a 0, y is also 0. Here only it is. Next is when x is a 0, it is a 0. When x is a 1, positive 1, y is a 1. X is a 2, y is a 1. X is a 3, y is a 1. So we can write this as like this. So this is what the Signum function. For any values of x positive, you will get a y positive values. If you take any negative values of a x, you will get a y negative, that is a -1. So last one in this, and we can complete this chapter with this function, that is greatest. Even this is also important one, greatest integer function. Here the function is defined from R to R by f of x is, so this is what the symbol, we can write it for the greatest integer function. Okay, this is a closed bracket, square bracket, and x is in real number. So assume the values of a greatest integer function which is a less than or equal to x. Okay, then such a function is called as a greatest integer function. For example, if you take x is a 1.5, this value is a 1 itself. If you take x is a 1.9, this is 1 only. Hope you guys understood now. From 1 to 1.9, the greatest integer function of such a value is a 1 itself. Okay, if you take it is a 2.5, it is a 2 only. If you take 2.1, it is a 2 only. It is the integer function, greatest integer function. Okay, so now we can write that as, if the greatest integer function, that is a negative, then x is a greater than or equal to -1 and a less than 0. X is a less than 0 and exactly equal to -1, and that value is a -1. When this is x is equal to +1, x is greater than or equal to 1 and less than 2. Less than is nothing but 1.9, which is not exactly 2, 1.9. From 1 to 1.9, the greatest integer is a 1. Okay, hope you understood this. So here, directly I'll just go with the graph. That is, this is x, x dash, and this is a y, y dash. So positive, this is a 1, 2 and a 3. This is -1, -2, -3, -1, -2, -3, 1, 2 and a 3. So now the value of this, so I'll just write it here, then I'll explain. So from this to this, it is again from 1 to 1.9. Next here is this, this, this is nothing bad. So from this here to here, 0.1 to 0.9, the function value will be a 0 itself. Then from 1 to 1.9, the value is a x, is nothing but 1 only. From 2 to 2.9, the function value is a 2 it is. Okay, similarly here. So from -0.1 to 0.9, the function value is a 0. Next, from -1.1 to -1.9, the function value is a 1. Next, from -2.1 to -2.9, then the function value is a 2 it is. So this is what the greatest integer function. So out of a 6, that is a identity, constant, polynomial, modulus, then signum, greatest integer. So these functions, out of a 6, any one question will be a compulsory from this for a 5 mark. Either they may ask any one of out of 6, but the important is a modulus, signum and a greatest integer. But these two are very simple. The last year they has this one, identity. Okay, so don't neglect any function, because you can thorough out all the 6 functions so that you can answer any one of that. Okay, hope you guys understood this. Okay, so this completes your chapter, a relation and a function. So next chapter will start with the next class. Okay, thank you guys.